Alright, in question number 3, we're given a bumblebee with an initial velocity of 3 meters per second, and we're told to find some different information depending on its rate of acceleration. So first off, we've got our little bumblebee. I'll just say that's our bee. He's got kind of the stripes and back, and he's going in that direction, so the positive direction is that way. And he starts off with his initial velocity, and then he has different velocities at the end depending on his acceleration. So for the first part of the problem, it's asking if he has a positive acceleration for 7 seconds, what his final velocity is. So for the givens, his initial velocity is 3 meters per second. His acceleration is 0.5 meters per second squared, and the change in time is 7 seconds. Now our unknown is the final velocity. So if we were to look at our equation sheet and look at everything that we have, we would see that the equation that it's best for us to use is velocity final is equal to velocity initial plus acceleration times time. We have acceleration time and the initial velocity, so we can really easily find the final velocity. So we'll just go straight into the substitution. So we've got velocity final is equal to 3 meters per second plus 0.5 meters per second squared times 7 seconds. And what that ends up giving us is the solution of 6.5 meters per second as the final velocity. Alright, so that was simple enough. Now you may be asking yourself, there's another equation that has initial velocity and final velocity in it. That's the final velocity squared is equal to initial velocity squared plus 2 times the acceleration times the change in x. The only problem with that is we don't know the change in x. And we could calculate that, sure, but it would be going out of our way to solve this solution. Alright, and for the second part of the problem, it says if the bee accelerates at a rate of negative 0.6 meters per second squared, how long will it take for it to reach a complete stop? Alright, so for our givens, we know that his initial velocity is 3 meters per second. His final velocity is 0 meters per second because we know that he's trying to stop and come to a complete stop, which is a velocity of 0. His acceleration is negative 0.6 meters per second squared. And our unknown for this is now time. And if you look at all the information we have, you would see that once again the same equation is going to be useful for this. So you've got velocity final is equal to velocity initial plus acceleration times time. And if we get this to a working equation, we end up with velocity final minus velocity initial divided by acceleration is equal to the time it takes for him to stop. So when we substitute in our values, we have 0 meters per second minus 3 meters per second over negative 0.6 meters per second squared. And here you can make sure that your negatives are correct, because if you look at it, we're going to have a negative divided by a negative, or a positive, which is going to be our positive time. Alrighty, so once you solve all of that, the solution that we're left with is 5 seconds as the time it takes for him to stop. Alright, now I know I blew through that one really quick, but that's because it was only using one equation, so I hope you were able to follow it. And now we're just going to keep on moving to question number 4. In question number 4, we're asked to find the distance that a ball travels after rolling down a hill. So to begin with, we have our little sketch. So we've got our ball with its initial velocity, which in this case is going to be 0 because it's starting from rest. We've got our little hill, and by the end of a certain amount of time, it's going at a certain velocity, and it has traveled a certain distance. Alright, and let's just say the positive direction is that way. So for our givens, we're told that its initial velocity is 0 meters per second. Its acceleration is 3.3 meters per second squared. And the amount of time that it is rolling down the hill for is 7.5 seconds. So using this, if we look at our equation sheet, and we know we're trying to find the change in x, if we look at our equation sheet, we'll see that the best equation for us to use in this case, with only using one equation, because for a lot of these problems what you can do is go the long way around and use two separate equations in order to find what you're looking for, whereas most of the time you can just use one simple equation and that's that. So in this case it's going to be x final is equal to x initial plus the initial velocity times time plus 1/2 of the acceleration times time squared. Alrighty, now we know we have that number, that number, that number, and that number. The initial x position is 0, or if we just subtract it to the other side, we have the change in x is equal to the initial velocity times time plus 1/2 of the acceleration times time squared. And since it's already solved for what we're trying to find, we can just substitute the values straight in. So we have change in x is equal to 0 meters per second times time, which is 7.5 seconds, plus 1/2 3.3 meters per second squared times 7.5 seconds, and that's squared. Alrighty, well that cancels because that's a 0. And our final solution, once we multiply this part out, is going to be 92.81 meters. And that is the change in x. Okay, so the main point that you should take away from this problem is that you should be looking for the equation that best fits what you need, because honestly you could have solved for this equation if you had found the final velocity by using the velocity final is equal to velocity initial plus acceleration times time. You could have found the final velocity and then plugged that into this equation to find the change in x. But that's a really roundabout way of solving that. So for the most part, you're going to want to stick to the simplest thing so that you're less apt to make a mistake. Alright, so now we're just going to move on to question number 5. Question number 5 asks us to find the distance that an object travels while accelerating to a certain velocity. Now, once again, in order to solve this problem, we could use multiple equations, but it is possible for us to just use one. Alright, so first things first, we have our sketch. That's going to be our object, and it's starting going at velocity, or its initial velocity. And it goes, and then it ends up here going at a final velocity, and we're supposed to find the change in x that it experiences. Positive direction is that way. So for our givens, we have its initial velocity, which is 5 meters per second, its final velocity, which is 15 meters per second, and its rate of acceleration, which is 2 meters per second squared. Now, we could use two equations, like I said, in order to find the unknown or the change in x. And in order to do that, what we'd have to do is find the amount of time that it takes for the object to accelerate from this velocity to this velocity. Find that time and then plug that into the equation that we used for the last problem. Instead, we can just use one equation, which is the equation that goes velocity final squared is equal to the initial velocity squared plus 2 times the acceleration times the change in x. And since we're trying to find the change in x, we have to do a little bit of changing for this problem. So we've got velocity final squared minus the initial velocity squared divided by 2 times the acceleration, and we've successfully isolated the change in x. So for our substitution, we have 15 meters per second squared minus 5 meters per second squared divided by 2, and that's times the acceleration, which is 2 meters per second squared. And when we solve for this and we multiply and divide everything out, the answer that we're left with is 50 meters as the change in x for this object. So once again, kind of a simple problem, but you're just supposed to be looking at these equations that you have and figuring out which equation works best in different situations. Alright, so we're going to keep on moving to question number 6. In question number 6, we're asked to find the acceleration of an object based on some other information given to us. Now it says that there are 3 methods to solve this, and I'm actually going to be walking through each of those 3 methods. So to start off, I'm actually going to not do a sketch, because the best way to sketch this would be to draw a position versus time graph and a velocity versus time graph, and those are pretty simple to draw, and they're honestly not essential for this problem. So for our givens, its starting x position is 3 meters, its final x position is 9 meters, its initial velocity is 5 meters per second, its final velocity is -1 meters per second, and the change in time, or the final time minus the initial time, or 8 seconds minus 5 seconds, is equal to 3 seconds. And the unknown that we're going to try to find is the acceleration. So for starters, I'm going to use the equation that is velocity final is equal to velocity initial plus acceleration times time. To convert that to our working equation, we have velocity final minus velocity initial divided by time is equal to the acceleration. The second way that we can solve this is by using the velocity final squared is equal to the initial velocity squared plus 2 times the acceleration times the change in x equation. When we want to isolate the acceleration, we have the velocity final squared minus the velocity initial squared divided by 2 times the change in x, or the x final minus the x initial. And that is equal to acceleration. Now our third way that we can solve this is by using the equation that's x final equals x initial plus the initial velocity times time plus 1/2 the acceleration times time squared. So we just move that over, so x final minus x initial minus the initial velocity times time over 1/2 times time squared, or since you've got a fraction on the bottom, that actually moves the 2 to the top, but make sure that it's times everything that's on the top. Alrighty, so I'm going to leave it up to you which you believe would be the easiest to plug values into. I personally would just go with this, because normally when you would want to choose fewer operations as opposed to more operations because there's less for you to punch in wrong in your calculator. So I'm just going to substitute for that first equation that I showed you guys. So we have -1 meters per second minus 5 meters per second divided by 3 seconds, or the change in time. And the answer that gives us is -2 meters per second squared as the acceleration. So the whole point of this problem was to show you that sometimes there are ways to arrive at the same answer through multiple ways. This time you could have used any of the 3 equations that we introduced in this unit. And we're just going to keep on moving to question number 7. Being a little more intricate and showing you guys what all you can do with these equations. Alrighty, so here we go.